We are just doing no, like we are talking about syllabus only and embedded system and etc. Little much about that.
Okay, okay. That means we only understood about the theory part in last session, right?
Yeah, yeah.
Okay. I was also telling about the same thing at that time, that if we have to install the softwares in next class, and we'll try to also understand how to install. If anyone having any problem like in installation, they can ask me. Right now, have you guys downloaded the package which we shared with you?
Yes, sir.
Okay. And is there anyone who is facing any kind of issues related to installation? No one. Okay, that's good. Uh, Very fastly, I'll tell you how to install the softwares, and then we'll start a little bit of practical part. In last session, we discussed more about what is embedded systems, what is IoT, what is automation, the type of automation, tools and techniques of automation. We even discussed about factory automation, software automation, hardware automation, right? So now today in this session, we are going to understand more about the practical one. So I'm going to share my screen. Okay, so I already shared this package with you guys, right? You already have the link. You just need to download this package. This is basically compressed file, right? A bundle file. Whenever we share bundle file, that means we want to save that particular software or that particular file from antivirus. So before extracting this file, first you have to turn off the antivirus of your PC, right? It might be possible that you don't have any antivirus, but in Windows 10 and Windows 11, we have the antivirus by default, which is with Windows Defender and Windows Firewall. So you have to turn that off, right? Very simple steps to turn that off. You have to search virus and threat protection. Okay, virus and threat protection. There, if you click it, here you will find the option real time. First, let me tell you, see, virus and threat protection settings. Here we have manage settings, and then we have real time protection. You have to simply turn it off, right? In my case, all others are already turned off. If in your case it is turned on, you have to turn off all the options from starting to end, right? And then close it. After this, now you have to extract this package. So to extract this package, you can use WinRAR software, okay? And otherwise, if you have Windows 10 or not 10, if you have Windows 11, the bundle package is already there. So you not need to install any other third-party software. You can simply double click on that file to view what actually we have in that folder. In my case, I am using WinRAR. So I just right clicked on this and I have an option extract to ES. ES mean embedded systems here. And once you click this, after the completion of extraction of all the files, it will create a folder in the same location, right? And there we can see 4 different folders: Arduino library for Proteus, Arduino 1.6.13, AVR Studio version 6, and Proteus, right? So first of all, you have to install this software, right? This is very simple. You have to simply double click, double tap on this, and next, next, next. And finally, once any problem? Okay.
Sir, can you repeat again?
Sure. What I said.
After. Okay, okay.
After what? So after extraction.
Sir, after extracting the software from WinRAR, can you repeat again?
Yeah, sure. After extracting the software using WinRAR or any other pre-installed software, you will get this folder, embedded systems. Simply you have to open this. And then here you can see 4 different folders: Arduino library for Proteus, Arduino 1.6.13, and AVR Studio, and Proteus. So in total, here we have 4 different folders, right? Now, if we see, first we have to install this one, Proteus. Proteus is basically a software which is related to electronic simulation. So using the Proteus, we can simulate electronic circuits, right? Now, what is the need of simulation? Simulation, in other words, I can say it's a kind of virtual hardware. Virtual hardware. That means without any hardware component, if you want to check how your circuit is working, you can create that circuit on this software and you can even test its working, its parameters, its graph, and everything related to your results. So what exactly I want to say, you not need to purchase any component, you not need to purchase any hardware until and unless you don't get the correct output. So once you create the circuit in simulation Proteus software and you are getting the correct output, then you can plan to implement that in hardware. That is called virtual hardware. That means without hardware, you can take the same output. This product is from Lab Center Electronics. The name of company is Lab Center Electronics. You have to simply double click on this to install. Okay. So if you double tap on this, it will give you the option to click next. I agree to the terms, next. And then it will ask a name of organization. You have to skip that part. It's not mandatory because the next
Sir,
option.
sir,
Yes,
sorry for interruption, sir. I already have Proteus 8.
no problem.
Can we use that for
No
this
problem.
process?
No problem. There is no issue.
Okay.
Yeah. So you have to now simply click next, again next, and the final screen is here. Install shortcuts for current user only and click next, right? Once you are done with all these things, it will install your software and then in your desktop, you can find the shortcut icon. In your desktop, you can find the shortcut icon like this, ISIS. So this ISIS is the shortcut icon for your Proteus software. If you are not able to create the shortcut icon, like after installation, you can't see the ISIS icon on your desktop, you have to simply open the C drive in your PC. This PC, here we have OS C. In your case, it may be local disk C or it may be Windows. So it may be with anything, any other name as well. So you have to open this one, right? Double click on this. Here we have program files and program file 86, right? If you have 2 folders, you have to access this one, 86 one. If you have only one, you have to access that one only, right? So simply now I'm clicking this 86 and here we have Lab Center Electronics folder, this one, Lab Center Electronics. You have to double click on it. In my case, I have 2 versions already installed in my PC, Proteus 7 and Proteus 8, right? But the version which I shared with you is Proteus 7. So you have to open this one, Proteus 7. Then you have to go to this bin, and after bin, scroll down. Here we have isis.exe blue colored icon. Simply right click on this. You have option send to desktop. In Windows 11, if you right click, you will not get this much option. So at last, there will be option of show more options. You have to tap on show more options. And after that, it will give you the same screen like mine and click send to desktop and create shortcut. That's it for the Proteus one, right? Now, after this, come back to another software. For now, you have to install this one, right? For the first or second class after this, like today's class and day after tomorrow, like today's and tomorrow's class, I'll be taking all simulations. I'm not going to tell you anything about the programming one. Day after tomorrow might be possible we start the programming. That time we need this AVI Studio 6. So you have to install this by the time, right? Simply double click. You have a file here is S6 installer 6.0.1703 full version. You simply have to double click on this. and click next. Whatever it is asking for, simply click next and wait for it. Once completed, you will see the shortcut icon like this, Atmel Studio 6.0, Atmel Studio 6.0 on your desktop. That's it. So this you have to install, right? No need to crack, no need to put any license file because they already have the license file. You not need to do anything. Simply install it, right? Last step, not actually the step, we already installed the softwares. The last thing which I want to mention, if someone is facing any doubts like started installation, but in middle of the installation, the file is showing some kind of errors. If you have an option to ignore, try to ignore that file. If you don't have an option to ignore, ultimately you have to cancel the installation. That means your file is corrupted because of antivirus. So just delete the file. Which file? Which you created after extracting the main file. That means this one. This one you have to delete, not the RAR file, because antivirus cannot affect this compressed one, right? You have to delete this one, close your antivirus, turn off your antivirus, and again extract the es.rar. I hope it is clear. Try these things, and still if you face any kind of issues or doubts, you can let me know by a message on WhatsApp. If I get time, I'll come to ask for the remote control of your PC, and then we will solve it mutually, right? Fine. Now, let me open this ISIS. So in last class, we discussed more about embedded systems, IoT, and all other automations part. In embedded systems, we may have many controllers like 8051, AVR, PIC, ARM, Arduino, Raspberry Pi, Onion, Omega. A list of controllers are there. We are going to use the one which will help us to reach the platform IoT easily. That way, I will suggest Arduino controller. But whenever we talk about the Arduino boards, there again we have a IC at Mega, and at Mega IC relates to AVR only. So what is the flow of content? First, we will try to understand about the AVR and AVR programming. That is why we are installing AVR Studio. So once we complete the part of little bit of robotics with AVR, then we will move to Arduino, correct? Because whenever we go for any interviews and you say, I know most of the things about embedded systems using Arduino, the interviewer can ask you which controller is inbuilt in the Arduino board. You have to answer that time about Atmega board, and Atmega mean AVR. So it may happen that interviewer is asking you more questions related to AVR. So that is why we will cover both controllers here. But in the case of AVR controller, we will discuss a bit related to robotics. As I said, AVR maybe I said in the last class that AVR is most concerned to robotics. Arduino is most concerned to IoT, right? So now let's start the simulation part from very basics, like small circuits. First, we need to understand how to use this Proteus software. As I said, Proteus software is the product from Lab Center Electronics, and the version currently which we are using is 7th one. You can use the next version 8th as well. If you see this Proteus, here we have this blue colored rectangular box, this one, right? So whatever components you are going to pick from the library of Proteus, you have to drop all those components inside this blue colored rectangular box. You don't have to drop any component outside this box. If you do that, that component is not going to be the part of simulation. That means you cannot consider or you cannot connect the wires to that component. So you have to drop all the components inside this blue colored rectangular box. You can zoom in and zoom out your screen using the scroll of your mouse, or otherwise you have plus and minus option here as well. right? Whenever you want to drag the position of your screen, here you have the option. Simply click, drag your mouse wherever you want. Once you are done, release your mouse and tap left. I'm repeating my words, what I said. Left click, drag your mouse. Left click, drag your mouse. And once you are done, release it and again click left. It's done. The reposition is fixed. Whatever components we need, Proteus has Proteus have almost all the components in its library. Now, how to access the library? So here we have option P. P is called pick from libraries. Whatever component you want to pick, you have to click on P. It will give you the option to search the components. And once you drop, you can drop it here, which is called L. L mean library manager. So there are two libraries here. The one is for software and the one is for user like us. So it might be possible that in the library of the software, there are almost 1,000 components. But when you are managing your library, maybe you are creating your circuit just with 2 components or just with 10 components or just with 50 components. So whatever components you are going to pick from the library of Proteus, you can see all those components here in the list of library manager. Now, once you click on P, it will give you the option to search like this. And you have to type the name, you have to type the keyword of the component which you want to pick. For example, suppose if we need a battery source, we simply need to search BATTERY. You need to recall each and every concept of electronics, correct? As this topic is somehow covering most of the part of electronics. Although we can say that IoT is related to electronics, IoT is related to electrical, IoT is related to mechanical, IoT is related to computer science as well. But this is obvious. Internet of Things. Things mean device, hardware, electronics. So we must have the basic knowledge of electronics as well. So if you are lagging in this topic currently, you have to recall, you have to revise whatever you have gone through in your first year of engineering, right? So what I'm doing, I just search the keyword battery and here we have the battery option. Simply select your battery, click OK, and now you can see the battery is dropped to your library manager and it is also displaying here as a picture. Now, if you want to drop it to the screen, you have to simply come to your screen, click anywhere on your screen, move your mouse wherever you want to drop, and you can drop it n number of times. You not need to pick it again and again. The component is already picked up. Now you are dropping. So what I did, let me delete all. How to delete? Select all and delete from keyboard. Control Z is the undo command and Control Y is the redo command. Again, I'm doing Control Z. How I deleted? Select how you select in Microsoft Office Word in the same way and then delete from the keyboard. And the second option is right click anywhere on your screen and you will get the option select all objects and delete from keyboard. Correct? What I said, if you already selected the component battery in your library manager, you not need to pick it again and again. You simply come to this box, click left. You can see the component. Wherever you want to drop, just again click left. So you have to tap left twice. Once, it will display. Twice, it will drop. Okay, let me delete. Now, suppose I'm going back to the P. P mean pick from libraries. And now this time I want to search another keyword like register RES. You have to remember the name of each and every keyword you want. If you want, you can note it down, the keywords, right? So I just search RES keyword for register. Here it is. Select OK and drop to your screen.
But sir, in the software, there are so many components are missing here.
In your software, there are so many errors. What?
The components are missing here, like Arduino are not available in this software.
And
so many sensors are there not available in this.
okay. Do you have any software where Arduino is already available and sensors are already available? I mean, do you have Proteus version 8 where you can see all the sensors, all the components are already available?
No, sir, I'm using Proteus 8, but in the software there is no any sensors.
Yeah, that's what I'm asking. You are using Proteus version 8, and do you have all those sensors and that Arduino controller already available in that version?
No, sir.
No, sir,
Fine.
to
Okay.
the external library for this.
Yeah, one last thing I want to ask. Are we discussing about any sensors or any controllers right now?
No, sir.
Right. So you not need to worry about. Leave everything on me. Okay. I'm here. I'm not going anywhere. Whatever I'm training you, just try to grab those things. Right. Once like 10 or 20 days pass, and now you have more questions in your mind, you are most welcome to ask me. But when I'm not telling you about sensors, controllers, why to waste your time on those things? Just try to learn those things which I'm telling right now. Okay. That is my problem. If your software is not working, I'll help you each and every step. Don't worry about it. Got it?
Yes, sir.
Okay, fine. So I was telling you about register, right? So what I did, I simply picked it from the keywords. I search it, RES, and here I can found the register. And then I dropped it to my screen. We know in the case of register, there is no positive and negative. So simply we can drop it. And the parametric value of this register is 10 kilo ohm, which we can change just by double clicking on this 10K value. How to change? Simply double click. Let's say I want to assign the new value to 1 kilo ohm. Simply write 1K, click OK. So now the resistance value is changed to 1K. And suppose if you want to assign it to 220 ohm, simply write 220. No need to write ohms here because in the case of kilo ohms, the ohm was not mentioned there. So simply write 220. Don't write K with it. Otherwise, it will become 220 kilo ohm. Now I clicked OK. So I can see the resistance size of 220 ohms here. Delete it. Now I'm going to pick next component as capacitor. Keyword is CAP. CAP. Now see what I did till now. I searched the component, selected, then clicked OK, then dropped to my screen. Don't we think that this is very lengthy way to pick all the components one by one and then drop it to screen? It will take too much of a time if we have around 20 or 30 components in a circuit. Yes. So what to do? Simply search your component and double click on that. We can see that is added in the library manager. Let's search the next component. The next keyword is I'm using for LED. There are a lot of LEDs available. We have to sort the list. So put one more keyword just with LED, LED animated. LED animated. LED animated is basically related to what? If you want to see the LED to turn on or to turn off, you have to search animated LED. You have options here, blue, green, red, yellow. Choose anyone. Suppose I want yellow one. Select, double clicked, I can see the LED is added there. Now, if I want motor, MOTOR, motor. Again, I have lot of motors available. I want to use this motor. So I search this one. Motor active, simple DC motor model. Double click. Now I'm clicking escape button to come out from this screen. And suppose I want to drop LED, select your LED and drop to your screen. Select your motor and drop to your screen. Select the capacitor and drop to your screen. And then in the same way, you can search any of the component which you want and drop to your screen. Is it clear to you? Any doubts to anyone?
No, sir.
Fine. Okay. Now, see, sometime it may happen. Suppose what you are doing, you want to drop a capacitor, and when you are dropping, you are lost to your screen. You don't know where you are. Sometime it may happen. Okay. So what exactly you have to do if you feel this thing? you have to simply click escape button from the keyboard. Escape button from the keyboard. And then come to this. Can you see some dots there? That means we have few components. See, actually, what you have to do, I am sharing my screen. So you have to follow my cursor wherever it is going that way, or that time I'm telling about that thing only. You have to listen what I am saying. You have to follow my cursor. So we can see here few components. Now let's set the screen to center. And now I can see I'm back to my home screen. Let's delete all the components. Let's drop LED yellow again. If you want to rotate this, right click, rotate clockwise, right click, rotate anti-clockwise, right click, rotate 180-degree, right click, rotate Y mirror. You cannot apply X mirror property on this because the object is vertically placed. If you rotate it clockwise, and now if you want to apply X mirror, it can be done because now the object is placed horizontally. Correct. Now let's delete this as well. Again, this was the way how to apply different properties to your object, to your component. Now suppose if I want to rotate the component before dropping it, so you have to simply select the component and rotate from here. You can see here the component is rotating. Okay, what I just did, selected the component and rotated here. I can see it's rotating. So whichever side you want positive, whichever side you want negative, you have to select and drop. Okay, fine. Now, if you want to relocate, if you want to drag the position, if you want to change the position of this component, there are two ways. The first one is select your component, drag it like this. And the second one is right click, drag object and drag it like this. You have to right click on the object, not the text. If you right click on the text, only text is going to drag. What I said, see, only text dragged. If you right click here, only text dragged. But if you right click just over the component, you can drag the whole component with text as well. I hope it is clear to you. Now let's create a small circuit. Okay. So what I'm doing, I want to turn on the LED. Simply let's take a LED. I'm rotating it to clockwise. The P junction is this one, the bottom one, and the N junction is this one, the upper one. Now let's drop a battery here. Let's rotate it clockwise. So positive terminal of the battery is bottom one. Let's connect it to here. Now how to connect? I'm going to zoom in so that we can see it easily. How to create the wires? Wires can be created just by connecting different nodes of the components. So this is called node. This is also called node. So if you connect node to node, it is called wire like this. Okay. How to do? Simply put your cursor on the node. You can see the rectangular box, dotted rectangular box. You can see the dotted rectangular box. Simply tap on that, move your mouse, and now you can see the component is connected to other component. Now let's connect this one as well in the same way. If you want to delete the wire, simply right click, delete wire. If you want to drag the wire, simply right click, drag the wire. I'm doing Control Z. Okay. Now the operating voltage of this battery is 0.7, not battery, sorry. The operating voltage of this LED is 0.7 volt to 3.3 volt. And if we see this battery, here we are giving 12 volt, which is more than enough for this LED. If you create this circuit on hardware, definitely your LED is going to burn within few seconds. So what exactly you have to do? You have to minimize the power. You have to minimize the voltage of this battery source. And how we can do that? Simply double tap on this and I'm making it 5 volt. Now the point is LED needs max 3.3 volt, minimum 0.7 volt. Why we have a range? Because LED has multiple colors and all colors have different intensities. That is why the required voltage is also different, ranging from 0.7 volt to 3.3 volt. But I'm connecting a battery source of 5 volt. It may also harm your battery. So you have to put a resistor in between. So let's put a resistor. There is no positive and negative in case of resistors. So you can connect it anywhere you want. So let's connect it here and let's connect the other terminal to the LED's end junction. And now if we see the resistor has 10 kilo ohm resistance, I'm changing it to 220 ohm. You can calculate it using V equals to IR, Ohm's law, or otherwise Kirchhoff's law. I just did it 220. And if I click on play, I want to see if circuit is working or not. How we can see that? Simply you have to click the play button on the left bottom corner of your software. If you click play, you can see the LED is glowing. That means your circuit is absolutely fine. Sometime it may happen the circuit is wrong, but still you want to see the LED on, and again you are tapping this play button. So you don't have to do this, otherwise your software will go to not responding mode. Simply click once on play, and here you can see the software is animating. If your software is showing animating here, that means the circuit is in play mode. And if you're not getting the output, that means there is a mistake in your hardware. There is a mistake in your circuit. Let's do the same thing as well. What now I'm doing, let's stop the circuit. The rightmost button on this panel is stop button. Okay. Now I'm changing the terminals, the wiring. How to do that? I'm now rotating this one. So now the positive terminal is there, connected with resistor, and this is connected with the negative of your battery, negative of your LED N junction, and negative terminal of battery I'm connecting with the positive P junction of LED. And let's click play. I can see the software is in animating mode, but the LED is not glowing. That means the circuit is wrong, because this is reverse bias case and diode does not work in reverse bias conditions. Correct. I hope you understood how to create a small circuit in Proteus. Now I'm going to create another circuit very fastly. Let's take 3 LEDs in the horizontal position where the positive terminal must be on left side. 1, 2, 3. Now suppose if I have a battery source of 5 volt. So how to make it 5 volt? Simply double tap here and make it 5. And then let's connect all 3 batteries in series. Answer me, is this circuit going to work or not? Anyone please? I'm connecting 3 LEDs with 5 volt of source. Is this circuit going to work or not?
Yes, sir.
No, it's not.
Yes, sir,
working.
it will work.
No, it will not work. The LEDs are not glowing. Because 5 volt is not enough to turn on all 3 LEDs.
Sir, because all the 3 LED needs more than 5 volt, because the sum of 3 LEDs is approx 9.9 volt.
Yes, you can say. Let's consider, as I told you, the range is 0.7 to 3.3. So why to consider the max? Why to consider the minimum? I'm considering in between that this LED is consuming 2.5 volt, right? This is also consuming 2.5 volt. This is also consuming 2.5 volt. So we need 2.5 plus 2.5 plus 2.5. That means we need a source of minimum 7.5 volt, because we know whenever we connect components in series, the voltage divides and current remains same. The voltage divides and current remain same. So if we connect 3 LEDs in series, the first is getting 2.5 volt. Battery source 5 volt, remaining 2.5 volt, second LED is getting. What third is getting? 0 volt. If it is going to get 0 volt, it will not allow other component. It will not allow the current to flow throughout it. That means the current going through this positive is not reaching up to the negative one, and hence the path is not completing. That is why all 3 LEDs are not working. So there are 2 ways. The first, increase the battery source. So let's increase the battery source to 12 volt and play. Now we can see all the 3 LEDs are working absolutely fine. And the other way, we every time not need to practice it. Like we are not allowed to change the battery source, because in future we are going to study about microcontrollers which operates at 5 volt of DC voltage only. So that time we will be getting only 5 volt. We won't be having any option to change the operating voltage to 12. That is why we have to practice with 5 volt only. So Control Z, making it to 5 volt. But if I click play, I cannot see the LEDs are glowing. That means the possible way to create this circuit is
In parallel.
in parallel. Exactly. Because in parallel, the voltage is not going to divide, it remains same. So let's connect 3 LEDs in parallel. So meanwhile, I'm creating the circuit. The time is about to complete for the session. You have to practice these things by today. Just after this class, we have to practice each and everything. And if you face any doubts, you can let me know. Tomorrow, we will discuss more about the circuits and simulation. Okay. And one assignment. How many LEDs we can connect in parallel so that all LEDs must work. All LEDs must work. So this is 5 volt and all 3 LEDs are working because all 3 LEDs are getting 5 volt of source individually because these are connected in parallel, and in parallel voltage remains same. Now what I said, you have to practice these things and you have to check one more thing. If we start connecting LEDs in parallel, how many LEDs are allowed to connect? Or in other words, if we connect 100 LEDs, so can we see that all 100 LEDs are turning on with the same 5 volt of source? This is your assignment. You have to check it. Whether you Google it or whether you try to implement reverse engineering. Reverse engineering means you can try to create the same circuit on the screen by adding LEDs one by one and check the output till which number LEDs are working absolutely fine. In series connection, we have a loss. Suppose if we make 12 volt of source and connecting 3 LEDs, all 3 are working, but we have a loss because there is only one path for the current to flow. If any of 3 LEDs stopped working, the whole circuit will stop. But in parallel, each LED has different path for the current to flow. So that means if any of the LEDs stop working, it will not affect other LEDs. This is same like the connections which we usually have at our houses. There we see if one bulb stopped working, the other is still working. Why? Because those are parallel connections. So guys, that's it for the day. I hope you understood each and everything which we discussed here. If you have any questions or doubt, you can let me know. Otherwise, keep practicing. See you tomorrow at same time with maximum energy. Okay, then good night. Bye-bye.
Good
Thank you,
night,
sir.
sir.
Have a good night.